Hi everyone, this is Minna. So today I want to discuss with you a topic which is web scraping in Python. So let's get into topic. The first thing that I wanted to discuss with you is our business case. So we are scraping a website which is a Wikipedia, uh, and we want to do two things. The first thing that we want to do is extract certain sentences that have specific keywords. And our second case is to extract hyperlinks and also give them to the user. But these hyperlinks will also contain certain keywords. So we're not going to extract everything on a website. We're going to choose. So this is our topic for today. So let's keep it short and simple. In order to start web scraping, in Python, we need to import or install certain libraries. We need to install them before we can import them. So I've commented here a couple of things that need to be installed. We need to install requests, Beautiful Soup, NLTK, and from NLTK we need to install or download a certain dependency. And we need to also install LXML. So these are a couple of things that we need to install before we can start importing. Because if we import and these libraries are not installed into our kernel, then we will have an error. So after we run these code, because I've run them before, so I'm not going to do it again, we are going to import. So the first thing we need to import is requests. We need these libraries because this is a library which will perform a request to the HTTP URL. So it will go to the URL itself and then request for this specific website to give us its content. And the content will be given to us in the form of an HTML content, which is in the form of HTML tags. The second library that we need to install or to import is Beautiful Soup. Beautiful Soup is a library which allows us to manipulate or convert the extracted or the requested HTML into the form that we want. And we will start extracting from it certain filters or certain sentences that we need in order to satisfy our business requirements. So this is what Beautiful Soup is intended for, and we will also know exactly how to use it in a couple of minutes. We also need to import URL join, and this is specifically going to be used when trying to also give the user a list of URLs that have a specific keyword. So we're going to give the user hyperlinks and certain paragraphs that contain keywords that they need. We also need, and we are going to know exactly how we will use this library. We also need to import NLTK, which is a library responsible for separating paragraphs into sentences based on a full stop or a dot. Okay, so we also are going to know why we need to do so. So let's get started. The first thing or the first function that that is the base of any web scraping is that one. The first thing that we want to do is use the library requests. So requests.get. This is a function that has two inputs. It takes as input the URL, and the second input is allow underscore redirects. And allow underscore redirects is set to true here because there are some websites that when you request or just type it on your browser, it gives you or redirects you to an intermediate website before it can actually take you to the target website that you need. So this is why I always allow this input or this parameter to be true, because at the end, overall, I want to reach my final target URL. If there is any redirection in the middle or intermediate thing standing in the middle. And then I initialize. So this is the first step. The second step is initializing beautiful soup. Beautiful soup takes as parameters two things: the R, which is the request made to the website. The request has a variable called content. So I take from it the content. And I allow this content to be in an LXML format. You can allow it to be in LXML, in HTML, and other formats, but I chose LXML. And then here, I want to get rid of certain tags that are unneeded. These tags can be scripts, hyperlinks, styles, and links. And then after, so this will be extracted and removed from the variable page underscore soup. Okay? And then at the end and finally, I say dot get text, page underscore soup dot get text, because I want the LXML to be finally converted into text format. Okay? So this is the first step. The second step is I also initialize beautiful soup, and I take the content of the request again, because remember, I wanted to extract the paragraph and I also wanted to extract hyperlinks. And here I got rid of hyperlinks by specifically saying that I want to extract this tag, this A tag. And A tags mean that these tags consist or contain hyperlinks. So I have to initialize a new one because this one will consist or contain all of these tags unremoved. Okay? And I return both of them. I return the page soup and I return the paragraph. So this is the first concept that you actually need to know. Okay? Let's explain these two functions as well. We have a function called sentences. Sentences takes the paragraph, which is that one. It takes the paragraph, okay, and it uses the library NLTK, and it has a function called sent underscore tokenize, which basically converts a paragraph into tokens, okay, and or it separates each and every single element based on an aspect, which is the full stop. So I say sent underscore tokenize and take the whole paragraph. Okay? I loop over each and every single sentence. Okay? And here I say, let's take it step by step. For the word in the paragraph words dictionary. So remember when I say I want to filter my paragraph based on specific keywords, if they're located or not. So here I say I want to filter based on this keyword, questions. Okay? So this means that if the word for word in the list of keywords that I've made, okay, take the first word, loop on each and every single word. And then here I say if this word is indeed in the first sentence, then please append it onto where, please append it on to paragraph underscore sent. Okay, append it. If it's not, then do not do anything. The third function here extracts hyperlinks. And what it does, it takes two inputs, the website URL and the soup. Remember, the soup here is basically page underscore soup. Okay? And a page underscore soup underscore new, which basically, as we said, consists of all tags. Okay? We haven't really extracted anything from this variable. Okay? So I say, please take from it all the tags which are A. And then I say, then I get the value of this tag. So I say A is equal to, first I loop over each and every single element that is here. I loop over each and every single element which is in the variable tags, and tags has all hyperlinks extracted from the website. How do I detect it? By the identification A. And I get its value by saying here tag.get href. So this is basically extracting the value of this specific this specific tag. Okay, this is a condition that I do just to validate that um, it's a hyperlink and just to remove any uncleanliness that could be an output of the HTML. So this is something that is optional. You can do so or not. But here I'm validating that it's a string. It belongs to a string type, and it has a length greater than 2. So again, this can be optional. Here, URL join. I use this because we have two types of URLs. We can have um, an absolute URL, okay, and we can also have, bear with me, um, relative URLs as well. So relative URLs are here URLs as we see here. They're URLs which are incomplete, and they can indeed be inside the HTML code of a website. But here, absolute URLs is the complete URL, starting from HTTPS, www dot, until the very end. So in order to avoid grabbing from the HTML relative, what I do here is that I use this library, URL join, in order to take the URL of the website and also the hyperlink extracted from the HTML source. And what it does is that if it's a relative URL, then it converts it into an absolute URL, and it appends it into the list. Okay? And then here I say for each and every single link inside this list. Okay, so here my hyperlinks consist all hyperlinks which are cleaned and which contain all absolute URLs, and everything is perfect and fine. I here want to filter my links furthermore according to what is contained in here. Okay, this is a list, okay, that also I filter my links based on. So I filter based on the word Jeopardy. Okay? So if every single word inside this link, loop on this link and get me each and every single keyword. And then I say if this keyword is indeed contained inside the link, please append it. Else just don't do anything. And I use here afterwards filtered underscore link in a function called set because it removes any duplicates. Okay? And then I return it. So let's see our concept itself, how we initialize the main function. I gave it a URL, okay? And from the function getPageParagraph, which basically sends a request to the URL, gets both the page soup and the page paragraph returned here. And then I send the function sentences the paragraph, and I send the function hyperlinks the hyperlink, and the page underscore soup, which has basically all HTML tags. And the last step is basically just printing each and every single one of them and running the main. So when I run the main, what happened from this from the output is that each and every single sentence that contains the word question is located inside inside the list. Okay, so you can here see the first one has question or questions. The second one also has questions, and so on. And also when I made the separate link that consists or contains all keywords that have the word Jeopardy also is appended into the other separate list. So I filtered my paragraph based on keywords. I didn't extract everything within a website. I only extracted the things that I wanted to filter based on. And I haven't really extracted all links. I also filtered the hyperlinks. So this is basically the concept of web scraping. It's very simple. It's very straightforward. And you can play around with it and just get whatever you want to do based on your business case. Okay, so thank you, and please subscribe to this channel. Thank you so much.